Hi friends, welcome to my YouTube channel. This is first part of lecture number 21 and today we are going to study circuit and waveforms of one phase half wave control rectifier with RL load. So this is circuit diagram of rectifier. Here load is RL type and we get output voltage V0 across this load. This load is connected in series with this thyristor and this whole circuit is supplied with voltage source Vs. We know that Vs is equals to Vm sin omega t and this is the waveform of Vm sin omega t. Now we will understand the operation of this circuit in three angular slot. First we will understand the operation from 0 to alpha, then from alpha to beta, and after that beta to 2 pi. First we will see the operation of this rectifier circuit from 0 to alpha. From 0 to alpha, the positive cycle of sinusoidal waveform is applied to this thyristor. So when positive cycle is applied to this thyristor, then this thyristor receives positive potential at its anode. When this thyristor receives positive potential, then anode to cathode voltage, that is VAK, becomes greater than 0. But thyristor is not fired or triggered yet, or we can say that gate current is not applied to the gate of thyristor. That's why this thyristor acts as open switch, or we can say that thyristor is in forward blocking mode. So during this mode from 0 to alpha, this thyristor acts as open switch. When this thyristor acts as open switch, then current in this loop is equals to 0. That's why we get output current I0 from 0 to alpha equals to 0. And what is output voltage V0? As this output current is equals to 0, that's why V0 is also equals to 0. And what is drop across thyristor? When this thyristor acts as open switch, then thyristor voltage becomes equals to Vs, or we can say that this supply voltage or source voltage will appear across this thyristor. And what is power output P0? We know that P0 is equals to V0 into I0, and both V0 and I0 are equals to 0. That's why we get output power P0 is equals to 0. So from 0 to alpha, here in this waveform, V0 is equals to 0, I0 is also equals to 0, and Vt is equals to Vm sin omega t, or we can say that this portion of sinusoidal waveform will appear across this thyristor. Now next is operation of circuit from alpha to beta. From alpha to beta, anode to cathode voltage VAK is still greater than 0 and gate current is applied at omega t is equals to alpha. So both the conditions to make the SCR turn on are satisfied. First, anode to cathode voltage is greater than 0 and second is gate current is applied. When both conditions get satisfied, then thyristor get turned on, or we can say that thyristor is in forward conducting mode. During forward conducting mode, thyristor act as short circuit. So this thyristor will act as short circuit. When this thyristor acts as short circuit, then the supply voltage Vs will appear across this load, or we can say that V0 is equals to Vm sin omega t. Now what is output current I0? Here I revise your concept that whenever there is inductance in the output circuit, then we get current up to beta. Okay, this is very simple concept. Now this is derivation of current I0. As thyristor conduct, then apply KVL in this loop. Then on applying KVL, we get Vs is equals to I0 into R plus L di0 by dt, and Vs is equals to Vm sin omega t. So putting this, we get Vm sin omega t is equals to I0 R plus L di0 by dt. Now this current I0 has two components. First is steady state component IST and second is transient component, that is equals to IT. IT can be simply calculated by putting this right hand side is equals to 0. So putting this, we get ITR plus L dit by dt is equals to 0. On solving this equation, we get transient current is equals to A e to the power minus R by LT. And how we calculate steady state current? We will calculate it by using network theory concept, that is steady state analysis. So we get IST is equals to Vm by Z sin omega t minus phi. On adding this transient current and this steady state current, we get I naught is equals to Vm by Z sin omega t minus phi plus A e to the power minus R by L t. So this derivation is based on the concept of network theory. If you have the concepts of network theory, then you can easily understand this derivation. But this derivation is not important from an exam point of view. I am telling this derivation for your knowledge enhancement only. So if you don't know this derivation, then how will you plot the waveform of current I naught? For this, you need to remember 3 points. First is, whenever there is inductance in the output circuit, then we get current out I naught up to beta. So first point is we get current up to beta. And second point we have to remember regarding this current I naught is, we know that in case of one phase half wave control rectifier with R load, we get maximum value of current at pi by 2, and we get current up to beta, and beta is equals to pi. So in case of R load, maximum value occur at pi by 2 and we get current up to pi. But in case of one phase half wave control rectifier with L load, we get maximum value of current at pi, and we get current up to beta, that is equals to 2 pi minus alpha. These all things has already been told to you in my previous lecture. So from these two we can conclude that for RL load, the maximum value of current will lie between this pi by 2 and pi. So we can say that this maximum value of current I naught, see this waveform, this maximum value of current I naught lies between, this is, suppose this is pi by 2, okay. So this maximum value of current will lie between this pi by 2 and this pi. And we get current up to beta, and beta for RL load lies between this pi and 2 pi minus alpha. So for R load we get current up to pi, and for L load we get current up to 2 pi minus alpha. That's why for RL load we will get current between pi and 2 pi minus alpha. Suppose this is 2 pi minus alpha, then we get current that is between this pi and this 2 pi minus alpha. So this beta for RL load will lie between pi and 2 pi minus alpha. Okay, in this way we can plot the waveform of I naught. Now here one important concept is, this thyristor will remain turned on till the output current I naught is positive. Or we can say that we get waveform of V naught is equals to Vs till the I naught is greater than 0, and we know that I naught is greater than 0 up to beta. That's why we get waveform of output voltage V naught up to beta. So from alpha to beta, this is alpha and this is beta. From alpha to beta, the waveform of sinusoidal voltage Vs will appear across this load. So this portion of sinusoidal waveform will appear across load from alpha to beta, and current is already shown here from alpha to beta. Now what is drop across thyristor? As I already told you that thyristor will remain turn on from alpha to beta, that's why we get drop across thyristor is equals to 0 from alpha to beta. And what is output power P naught? Here P naught, for P naught we can see that from alpha to pi, this V naught is positive and I naught is also positive. That's why we get output power P naught positive. Means the flow of power is from source to load. But from pi to beta, this V naught is negative and this I naught is positive. So we get output power P naught that is negative. Negative power means the flow of power from load to source. So here we get positive and negative power from alpha to beta. From alpha to pi we get positive power, from pi to beta we get negative power. Now we will see the operation of this circuit from beta to 2 pi. At omega t is equals to beta, what happens? This current I naught becomes 0. When this current I naught becomes 0 and VAK is already less than 0, because after pi polarity of sinusoidal voltage reverses, that's why at point beta I naught becomes 0 and VAK is less than 0, then thyristor goes into reverse blocking mode. Because for reverse blocking mode this I naught must be 0 and this anode to cathode voltage must be negative. Both conditions are satisfied. That's why we can say that thyristor is in reverse blocking mode. So when thyristor get turned off at omega t is equals to beta, then in that case thyristor act as open switch. When thyristor act as open switch, then current in this circuit I naught becomes 0, or we can say that I naught is equals to 0, and output voltage V naught also becomes 0 because current is equals to 0. And what is drop across thyristor? When this thyristor act as open circuit, then the source voltage Vs will appear across this thyristor. That's why we get thyristor drop Vt is equals to Vs, or we can say that this portion of waveform will appear across this thyristor. And what is output power P naught? As both V naught and I naught are equals to 0, that's why output power is also equals to 0. So this is all about this video. I hope you like this video. Thank you. Jai Shri Ram. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.